Hey, geometry. So today we're going to talk about 1.5, which is angle relationships. All right, before this in 1.1 and 1.4, those chapters was all about more points, lines, segments, rays, planes, that kind of thing. But now we're going to move on to angles. All right, so we did talk a little bit about angles, but a little bit more specifically, we have something called adjacent angles. All right, if things are adjacent, that means that they are next to each other. So if I draw two angles here, right, here is my first angle. And let's call this angle BAT. All right, so we've got angle BAT. An angle adjacent to this would basically just mean that it has a common vertex. So A is my vertex right now. I'd have to have another vertex at point A. And then one of the sides are shared. So remember, the sides are AT and AB. So it has to share one of these sides. So if I drew another ray here, and maybe we call this point G, that would mean that angle TAG would be adjacent to angle BAT. All right, those are two adjacent angles. All right, so I'm going to just kind of highlight these here as best I can. So we got this red angle here, and then let's highlight the other one green. All right, we got these two different angles. There we go. So we can say that angle BAT is adjacent to angle TAG, right? They have to have a common vertex and they have to have a shared side, and then they are therefore adjacent, right? Notice there's also no common interior points. So if I pick a point that's inside angle TAG, it's not also inside angle BAT, all right? Completely separate. There can't be any sort of overlap. Linear pair, all right? These are adjacent angles that also have sides that are opposite rays, right? Opposite rays, remember, form a straight line. So basically what we have is we get a straight line going here, and then from somewhere on this line, we now have two opposite rays. I can draw another ray coming off of this. Notice how I have now created two adjacent angles, right? There is a large straight angle here, but I've also created two other smaller angles. And so again, we can look at this, and if I highlight, we've got this larger obtuse angle here. And in addition to this larger obtuse angle, we've got this smaller acute angle. So these two angles are adjacent to each other, and these are also a linear pair because they do add up to 180. All right, so I'm going to call this angle 1, I'm going to call that angle 2. So we can say that angle 1 and angle 2, sorry, not are, we're going to say form a linear pair. All right, so these angles form a linear pair, again, because they add up to 180, they form a straight line, and they have, they're adjacent to each other. All right, so they form a linear pair. Vertical angles, all right, these are non-adjacent angles that are formed by intersecting lines. All right, so if I get two lines going that intersect each other, here's one line, and then let's go and we can draw another line just like this that intersect. Okay, so at our intersection point, we get 1, 2, 3, 4 angles here. All right, so the vertical angles are the angles that are directly across from each other. All right, so that would mean that angle 4 and angle 2 are vertical angles, right? They form a pair, they're vertical angles. And then across from 3 is angle 1. So angles 1 and 3 are vertical angles. All right, so angle 2 and angle 4 are vertical angles. And then we're going to say angles 1 and 3 are vertical angles. All right, so they kind of have this like pairing up relationship. All right, now the interesting thing about vertical angles is that they are always going to be congruent. For example, let's say I said that angle 1 was maybe 60 degrees, okay? Well, we know that 1 and 2, these form a straight angle, right? We've got this straight line right here. So I know that angle 2 is going to have to be 120 degrees because I have to add up to 180. And then if I look over here, I know that these two angles also have to add up to 180 because we have a straight line. So that means that this is going to have to be 60, and then you can go back around here and angle 4 is going to have to be 120. So you're always going to see this relationship, all right? Once you figure out one of the angles, you're always going to be able to figure out all 4 of the other angles, okay? So next up is complementary. These are two angles with measures that sum to 90. So if I get a right angle drawn here, we're going to get this right angle we have, right? And put that little box in the corner to show it's a right angle. I can then draw another ray coming off this vertex anywhere I want. Doesn't matter where. Let's just say maybe over here. And so if I call this angle 1 and angle 2, we can say that angle 1 and angle 2 are complementary. All right, so angles 1 and 2 are complementary. We also know that the measure of angle 1 plus the measure of angle 2 is equal to 90. All right, that's their measure. Supplementary angles. This is kind of like a linear pair, a little bit different. We'll talk about that in just a sec. So I can draw the same situation I drew above with a linear pair. All right, I can draw, opposite rays with another ray coming off of it. And we can say that, yeah, angles 1 and 2 are supplementary, right? In this case, angles 1 and 2 also form a linear pair, all right? So I'm going to say angles 1 and 2 are supplementary. I'm just going to abbreviate that. And form a linear pair, all right? But for supplementary angles, they don't have to be adjacent to each other. So in a different example over here, we could show that I've got maybe a obtuse angle here, and then maybe separately, I've got an acute angle over here. All right, so maybe we'll call this angle 3 and angle 4. And, let's say if angle 3 was, let's go back to the example we just used. If angle 3 was 120 degrees and angle 4 was 60 degrees, then we could say that angles 3 and 4 are supplementary. All right. However, in this scenario, angles 3 and 4 do not form a linear pair because they don't make a straight line. All right, they're not adjacent to each other. So you can have supplementary angles that are adjacent and form a linear pair, or you can have supplementary angles that are not adjacent and do not form a linear pair, but they still are supplementary. All right, perpendicular, our last word for today. Perpendicular is a word used to describe lines, not angles. So you would never say that angles are perpendicular. You would always say that lines are perpendicular. All right, so lines are perpendicular. And then we would say that angles are right angles. Okay, so we don't say perpendicular angles, we say right angles, and we don't say right lines, we say perpendicular lines. All right, we do have a symbol for perpendicular, and this is an upside down capital T. All right, so that is the symbol that you're going to see quite often. This is the symbol for perpendicular. All right, so for example, if we go ahead and we draw two lines, and these are going to intersect to form right angles. So we draw that right angle there. We can number these 1, 2, 3, and 4. All right. But again, if I want to talk about, things being perpendicular, I have to make a mention of the, of the lines, not the angles. So I can call this, let's call this line L, and let's call this one down here line M. All right. So I can say that line L, I'm actually going to do an if statement here, an if-then statement. I'm going to say that if line L is perpendicular to line M, then angle 1, angle 2, angle 3, and angle 4 are right angles. Okay, so if you have two perpendicular lines, you are going to get all four of these angles that intersect to be right angles. All right, and again, as we get closer and closer to proofs here, you're going to see kind of how this flow works, right? As we talk about, if this is our situation, then this is the result. And then you might even think, well, if these are right angles, then they're all 90 degrees. All right, so you can kind of see how that flow is going to go, where you have a given statement, and then that's going to allow you to say something else. And then what you just said is going to allow you to say something new. And then that's going to allow you to say something. So you're going to kind of have this flow to how you prove these statements. All right, so after you've watched these and finished your notes in the packet, please go ahead and start working on the 1.5 study guide and intervention packet that you have with your group members. Once you finish that, there is homework that is posted on Canvas.